In this webinar, we will see how to create and share Simulink simulations as standalone applications built using MATLAB App Designer and deployed using Simulink Compiler. For this presentation, I'll be using a model, a Simscape model of a solar panel from the documentation. It is available in the documentation. And I will create an app in MATLAB App Designer. Later, we will share it as a standalone application to run the simulation and to obtain power voltage curves from the solar panel by giving the inputs as irradiance level and cell temperature. The final outcome of the webinar is a standalone application that can be shared with collaborators, suppliers, and clients. Why to create simulation apps? Simulation apps can be used as a black box for specific tasks. They can be used for desktop and server applications. And in some cases, the end user is not familiar with Simulink, and also he might not have MATLAB and Simulink installed. So he can still use this apps and he can run the simulations. And reuse of the existing simulation models. So today's webinar workflow will be like this. So first we'll be creating a Simulink model. Then later we'll be designing an app. Then deploy the app. After the deployment, we'll share it and we'll see how the app works. For the Simulink model, I'm choosing an example from MathWorks documentation. So this is the example I'm choosing. Solar Panel Parameterization Validation. So in this example is available in renewable energy examples, which is a part of Simscape Electrical. For those who are not familiar with Simscape, it is used to model and simulate multi-domain physical systems within the Simulink environment. So this is example renewable energy examples, and here you can see on the contents that it is a part of Simscape Electrical. And when you open Simscape Electrical, we can see all the examples related to Simscape Electrical. So here we have examples for, and also we have documentation. And the examples we can see, like there's a lot of examples. You can use the reason I'm showing this example is that you can use these examples to start with your models. You can use these templates for in every category. We have like examples. So there are plenty of them. You can go through all of them, even related to battery and stuff. So also you can see that Simscape also not only Simscape Electrical, Simscape also has Simscape Driveline, Simscape Fluids, and Simscape Multibody. And you can find the examples for all these models. So I'm taking one example from this to demonstrate in this webinar. Then for designing the app, we will use MATLAB App Designer. With MATLAB App Designer, you can design, you can create desktop and web apps in MATLAB. You can build apps. So this is the product page of the MATLAB App Designer. So you can also, there are a lot of components which can be used in your graphical user interface. You can drag them and drop down. And for this, in my previous webinar, I've already explained how to create apps in MATLAB. You can find this video on our YouTube channel. So, and also after you create an app, you can start sharing them. You can share them as MATLAB apps where MATLAB users can use it, or you can also create them as standalone desktop and web apps. Next, MATLAB has come out with a solution to share simulations with the help of Simulink Compiler. And this was first introduced in the release 2020A. With this, you can create royalty-free apps. So this is a Simulink Compiler product page. This is a Simulink Compiler. So you can share simulations as standalone executables, web apps, and functional mockup units. If we go through the documentation page, we can see that you can create simulation apps. Today, out of all the capabilities, I'm choosing Simscape as a capability to create the app. Then you can create, also with this, you can create a browser-based web apps. In case you have a constant maintenance or you have to change something in the app, you can have it in a centralized place and you can host it as a web app. And also you can use it in enterprise applications along with production server. Also, you can create standalone co-simulations using functional mockup units. You can use this in digital twin workflows for parameter estimations. After you, after that, you can start sharing as standalone applications, web application, and MATLAB applications. All this is one workflow. Another workflow is to use automatic app generation. In the in the previous one, in this workflow, you will not create an app in the app designer. From the model, you will directly get an automatically generated app, and this feature was actually introduced in release 2020A, and they have introduced this function called Simulink Compiler Gen app. You can use this to automatically generate app. So what this function does is this function analyzes your Simulink model and generates a deployable MATLAB app to Simulink the model in rapid accelerator simulation mode with different input parameters and initial states. So in this webinar, we will be seeing two things. One is creating a we will create Simulink model, and we will actually create in App Designer, we will create the complete app, then we'll deploy as a standalone application. And second workflow, what we see is from the model, we will see how to automatically create an app without actually designing in App Designer. Then we're gonna convert into standalone and test it. So let's start building. Let me open my MATLAB. So this is I'm using LiveScript in MATLAB. So I've already written the code here to make this webinar easy. So let me first this is the first workflow which I'm following of building an app in App Designer. So first, what I will do is I will build an app. Sorry, I'll open the model from the documentation which I've showed you before. Then I will take copy the model and build my own model according to my requirements. Then I will use this model and I will write the code to test it in MATLAB to see if this model is working. Then after I run this code in MATLAB, then I'll go to the app designer. In the app designer, I will create the GUI, then copy the code which I used in MATLAB for testing. And then later I will add I'll configure it for deployment and then we'll convert it into a standalone application. So first, let me open the model. So this model I'm opening from the documentation, renewable energy. So this is the offline documentation what I'm opening. So here, this is the example I'm choosing, Solar Panel Parameterization Optimization. So I directly open the model. It's loading. So the model is here. Let me minimize this. So let's make it big. Let's see this. So this is a model which we'll be using, and also all the parameters related to this are loaded in the workspace. I'll create a new model by selecting a blank model. So I'm taking a blank model here. I copy the content from this, copy it, and paste it here. Also, you can drag it, and also this one. This is a time. So I copy this and I paste it here, time. Let me open the model. So this is a model now. So I'm going to make some changes to this. So let's see what is inside the solar panel. So the solar panel is like the solar panel subsystem model contains parallel and it actually contains parallel connected strings of series connected solar cells. And the solar cell strings are modeled by a single cell. Let me open this. Look inside the mask. So it has only single cell block from the Simscape, and this is a solar cell physical block. So in this we have not used many cells. Actually, we can connect these cells in series and parallel and make it as a big model. Instead, what we did is like we are using only one cell because we don't want to slow down the simulation by adding more number of blocks. Instead, what we did is like to avoid this, we used a controlled current source scale up. Okay, this will fulfill the demand of the parallel paths. And here we have a controlled voltage. Okay, this is like instead of adding a load, we have a controlled voltage source. So with this, we are giving input voltage as 0 to some value, and we are controlling the voltage. So this is like kind of acting as a load in this case. I want to add few components to this model and then save it to use it for our demonstration. So I'll copy this and I drag it a little here, make space to add some components. So okay, so here we have library browser. Okay, you can access components from this. So here you can go to Simscape and Simscape electrical, and you can there are plenty of components. Like you can go through all the components, you can access them, or if you're familiar with the components, you can double click on this canvas and you can get the components. So this I'm using a current sensor and I need a scope to see the values. So I have a scope. So this is a physical component and this is a Simulink component. So when you see here, the symbols are different. So if I try to connect, I cannot connect. Okay. So what I do is for this, I need a physical to Simulink converter. So we say PS physical signal to Simulink converter. So I connect this with this using this. So before doing that, let me connect the current sensor. So the current sensor is connected. Then we have this connected here. And I have my scope. I'm connecting to scope. So now current sensor is connected to the scope. So we can see the values. In the scope, I want to see another parameter. This is current. So there's another component that is voltage. Okay, I will connect this signal to the scope. So this is also there. So this is voltage. and I want to see the power. So to get the power, I can have the product of current and voltage. So I take the block called product, resize it, resize this one also. So I connect it here, make some space, arrange the blocks. I connect this to the current and the other one to the voltage. So this is voltage. I'm naming my signals and double clicking on this, and I can name it. This is power. So the model is ready, and here time will be our input. So let's run this model and see if it is working. So yeah, so let's check the scope for the results. So yes, we have current, power, and voltage. To know which one is power and which one is voltage, I go to view and I go to legend. So I get this thing notification here. So I can see that current is yellow, power is blue, and voltage is orange. And I can also go to layouts. Sorry, I can go to view and I can go to layouts and I can add 3 graphs to view them separately. And I run them. I see the graphs scaled properly. Okay, so it's running. So next, what we're gonna make some small changes to the model. Before we do that, we have like, I want to explain this. There are 3 modes uh, in Simulink simulations. It's called normal mode, acceleration mode, and rapid acceleration mode. To deploy the apps, we run the models in rapid acceleration and test them. If it works successfully in rapid accelerator mode, then we can deploy them without any errors. So rapid accelerator mode is actually, um, it uh, um, it creates a rapid accelerator standalone executable from your model. This executable includes the solver and the model methods, but it resides outside of the MATLAB and Simulink. It uses external mode to communicate with Simulink. So it has both solver and model outside the Simulink, and whenever we call it, so it communicates with Simulink using an external mode communication. So what we do is now we we saw that it's working. So let's delete these, and we'll add ports to this output. So output 1, this is output 2, output 3. So I had 3 ports, and I run this in rapid accelerator mode. Then I run this. So when you're running it in rapid accelerator mode, initialization will take time, but when you're running, but runtime will be less. So now we can see what is happening during this. Then here we can see that code generation, generating code templates completed. Launching rapid accelerator, allow access. So this is ready. So we'll see the diagnostics and we see that there are no errors this is errors and these are warnings. There are no errors and no warnings. So the simulation there, it is compatible with Rapid Accelerator. And this is saying that the model is generated. Okay. So let me minimize this a little. Then now these, all the values, all the variables like irradiance, if I go inside this, let me go inside the solar. So we have all the parameters, all these parameters are right now coming from the workspace. And these parameters are launched uh, with the example model, which we saw. So if I close example model, if I close this example model, all of these workspace values will be erased. So let me save these in mat file. So I already saved this before. Okay, so this I'll be using this. So I've saved all of them here and I kept them. So now let's close all the models, even this model. I have to save it, but I already saved it as solar. So now next step is that we will start. Now we have completed building the model. So we have the solar model and we have the workspace variables. So both of them are here. Let's here. Next step is that I'm loading the first. Let me clear the screen. Clear the workspace. So everything is clean. So now we'll load the variables and also solar and we'll also load the model. So this is the first step. So this is the model, what we have just created. So now the second step we are going to do is we're creating a script, okay, in MATLAB, and we're going to run from MATLAB. We're going to run Simulink from MATLAB and Rapid Accelerator mode and see if the script is working fine. So before we do that, I will try to open some documentation to show you guys this one. So here, if you see solar here, to deploy standalone applications, you can use these functions which are listed here. So create and deploy standalone application with Simulink Compiler to run simulations on target mission. We can use these ones, these functions. So now using, and also you see, I will be using this one right now, Simulink Compiler configure for development. And also I will be using Simulink simulation input. So Simulink simulation input creates a Simulink input objects that make changes to the model for multiple or individual simulations. So you can give initial states, you can give model parameters, block parameters, and all of those things. So you can give variables to the model. So let me show you the script here. So first step is that create the Simulink simulation input object, and this I'll explain you this button later on. This one. First, we're going to create this object. So what we do is first we'll give the name of the model as solar, and we're creating the simulation input. So this is simulation input. This one. So as I've told you that I'll open help in this. So I showed just now, I've showed you guys this one. So I'm using this. Then after I create the simulation input, I want to set variables, tunable parameters in this. So to give the variables, so I use set variables and I'm giving it. So in this, I'm working on only two parameters, that is irradiance and temperature. So irradiance and temperature. So these are the two variables that I'm going to set. And also I'm going to set the uh, stop time for the simulation. So stop time will accept input as string. So I'm converting a number here. 40 is the number. I'm converting 40 to string. and also we are setting the simulation to run in rapid accelerator mode. So it's written here rapid. After this, we run the simulation using sim command. Then after that, we extract the results and we plot them. So let's run this and see. So this is running. So this is building some building summary. And we can see here, because I'm using the live script, I can write the text and I can have the code, and also I can see the results in the same page. So these are the results. I haven't named them. I'm not giving them titles, but from here you can see. First one is time versus current plot. Second one is time time versus power. The third one is time versus voltage, and the fourth one is voltage versus power graph. So when I run this, I can see the simulation. So this is working good. So what I do is I copy this whole script. Uh, okay, I create this. Now this is working. So next shift to designing the app. Since we have the code, we have the model. Now let's design the GUI for this. So for that, we have to go to the app designer. And in the app designer, I will be creating a GUI similar to this. So I will have a picture of the mod solar panel. Then I will have parameters, irradiance, temperature, and time. And I'll have a button, simulate button. Then I will have this current plot, voltage plot, whatever we have seen here, all the four plots will be here. So let me launch the app designer. Also, you can open app designer from here. Open, go to this one, new, you can go to apps. Okay, open apps. Okay. Let me get this here. Sorry. It's open in my other screen. I'm trying to drag it. Yes, it's here. Okay. So this is the app designer. So app designer has two pages, two pages. So one is design view and the other one is code view. So what you're going to do is in the design view, so these are the component libraries. We have a lot of components here. Like you can see here, you have buttons, axis, checkbox, and all this. So you can drag them and drop them like this. And after you make your GUI, you can go to the code view and give and create callbacks functions for the GUI components. That means you can create the behavior for the components. So, okay, let's get started here. So I'm not going to explain in detail about the app designer since you have another video for this. So first what I'll do is I'll take a grid view. I'll place a grid view. And here I'm expecting um, uh, one, one by, I don't need this. So I have this. 1 second, sorry. Just close this. I'll take the label. I'll give the label here first. So this will be the heading, title, sorry. Solar Panel App, and you can, and here you get this. You can change the font. You can change the font here. Okay, you can change the size here. Like I'm gonna make it 24 now, so you can make changes in this side. Then I take the grid, place a grid layout. Okay, so after that, I again take another grid and I'm going to place it. Now I need 3 layers, 1, 2, 3. So 3, and I need 2 rows for this. No, so I need, sorry, I need 2 here, 2 columns and 3 rows. 2 columns and 3 rows. Let me align it properly with this. Okay. So in this, first I'm gonna, I need a picture. So I will use images here, image, and I'm gonna drop and drop it here. Then I will have graphs. For the graphs, I use axis like component. So 1, 2, 3, 4. Here I will get another grid. Here I will have 4 components. Here I need 4 components. So first we will have a edit field for irradiance. Another one for temperature, panel temperature. Then another one for time, simulation time. Then we'll have a simulation button. Now we can edit, we'll start editing this. So here you can either go here, you can change it, you can change from here, irradiance, or you can double click here and you can change it from here, temperature, and also this is simulation time. And this is simulation button. I would like to change the color of this. So this will be stay green. Then after that, let's come to the graphs. Same way you can change the title of this one. First, let's change the x-axis. So x-axis, I'm clicking Control, selecting all the 3. These 3 will have x-axis as time. So changing time. Then here, this first one will take as current. Second one is power. Third one is voltage. Then we have voltage versus power. Power. If you want, you can change the titles. At the moment, I'm not changing any of them. Adding. Same way, either you can double click here and change, or you can type, write it here. Okay, to add the picture, you can click on this browse and you can select a picture. Okay, this is not in the path. I have to click the picture, so I haven't clicked it. So let me get it from the place, or let's click the picture now. So we have the picture, and these are the variables, and this is the simulation button, and these are the graphs. So now what we do is like the GUI is ready. Now we have to go to the code. Okay, so we want to click this button and we want to simulate the whole thing. So for that, we have to go to the callbacks, add callback uh, function. So here you see everything is already written. Whatever is in the gray, you can't change, you can't edit it. And only the content in this white you can change, or you can add, or you can edit it. So this is like a good thing that MATLAB will create the script, the code for you. So we want to get the code here. Let's go to MATLAB and we'll copy the code which we have created before and we'll paste it here. So let's go to MATLAB. So what I did is like I copied the whole code and I kept it here, Solar script. So I accept this. Let me delete this. So we have this creating, and these are the variables, and some of them are unnecessary variables, and this is here. So this is the script. So this is in live script. If I copy the live script and paste it in App Designer, we will these all will be like we will not have a good uh, it cannot differentiate between the code and the text. So what we do is we save it as we save this script as, go to live, okay, and save as MATLAB script. So live script is now converted to MATLAB script, and whatever is supposed to be the text, you can see here, it is converted to text, and whatever is the command, it is just kept like that. So now you can just copy the whole thing from here. I'm copying it, and I go to the app, and I paste it here. Later, I can copy this, and I will move this. So your script, I've written nothing. I just tested it in MATLAB. I'm copying and pasting it here. Now to the script, I need to make some changes. So the changes are, I have to get value from the GUI. So I have to connect irradiance to the GUI. For that, I remove this. And we can see here, whenever you're working on the code view, you also have the app layout on the left side. So when you can interact with it. So when I click on this, I can see this is highlighted here. So app.irradiance edit field. So I can use this name, app.irradiance. So when I'm typing, it suggests me the available components. Edit field dot value. For the temperature, same thing, app dot um says temperature, right? So temperature edit field dot value. Then we have time, simulation time. So here in this case, the simulation time, what the block which I've taken is numeric one. So also you have text, I choose numeric, so I don't have to, in this case, again, I have to convert numeric to string. If in case I'm using this block, I don't have to do it. But since I've already chosen the text and values, so I'm using this. So here it will be like app dot um, simulation time, simulation time edit field dot value. So this will be in the form of number, then it will be converted to string and it will be pasted here. So same thing. So here we have the simulation plots. Now to this, I have to add another, for the deployment, I have to add Simulink Compiler, right? So for that, we have this code that is, so next step is configuring it. So I have to add this code, configure Simulink for deployment. So it is Simulink Compiler configure for deployment. So I copy this, I go to the app and I place it here. So the app is, so all the content is here. So everything is ready. So let's change. Oh yeah, we have to change another one. So these are the outputs. So we have to also connect the plots to the GUI. So first we'll change this one. We'll change this to current. We'll change some parameters. First one will be current. Second one will be power. Third one will be voltage. So here for the plots, I have to add app dot UI. So UI figure. So you can see here, like first one is UI axis, right? Yeah. So this is a plot, first plot. The name is UI axis, not figure. UI axis. UI axis. And this one will be T, right? So it's a T, same T, or I can write it as time. And the parameter one will be voltage. Current, sorry. So now you see when I put the current, so automatically this line went off. So whenever you write some variable which is not used in the code, it highlights like this. So also now I copy this one. It will be easier for us. Paste one to the next line and this another line. So I delete these. So this will be axis 2. The name of this will be axis 2. So this will be axis 3 and this will be axis 4. So this will be power, voltage, then we have voltage versus power. Okay, so the app is ready now. So we have the GUI, we have the code for the behavior, and also we have we are using Simulink compiler. Now let's run and see if this works before we convert to standalone. So I run here. Okay, first we have to save this Solar app. So the app, so this is the app. So we the way we have designed it, so we have all of the components here. So here in this case, initial values are all zero. Let's give values. So it is 1000. Irradiance will take us 1000. Temperature is 25 and simulation time is 40 seconds. So when you run it, okay. So you see, when I run it, I see all the graphs here. So this is the current, power, voltage, and all. Also, you can interact with this, with these icons over here. Also, you can save it. So, so what we do is now, when the app opened, it was blank. It was starting with zero. Okay. So what we do is we'll give some initial values to this. So I'll close this. Again, I go to the design view. Sorry, code view, or I can go to design view. Yeah. I can click on this irradiance. You can see the value. So this will be the initial value. Okay, I give 1000. Also, you can give the limits. And this will be 25. And this will be 40. Okay, so now I save this again. And I run it. So I see all of them. So simulate it. So I see the simulation. Now I change the values here. And it runs. Okay, okay. This is one thing. So next what we do is, so this is working. So also when we go to the model, there is one thing we have to change. So in the model for the Simscape blocks, we have a thing called we have this thing called runtime and compile time. Okay. Um, by default, all the Simulink parameters are compile time. Okay, which means you cannot change the value of the compile time parameters in the model or in the generated code without recompiling the model. But so what I did is, in this case, if a few options, you have this thing compile time and runtime. So I want to change the value of this temperature, your runtime. So I select this as the runtime here. Okay. By default, it will be like compile time. So this is one thing I didn't show. So now, okay. So now we have designed the app and we generated it. Now let's convert it to standalone application. So for that, we go to the designer tab and we go to share here. You can also see MATLAB web. Whatever I'm doing for standalone, it also applies for web and MATLAB apps. And maybe there'll be like few additional steps to do. In MATLAB apps, you don't have to do a lot. The web app, maybe you need to add like one or two steps. So standalone app, I click on it. So when I click on it, okay. So here you can see the type. So this is, we're going to create as a standalone application. And here in the name of the file will be this one, solar app dot this one. And here you can see the packaging options. There are two packaging options. After you convert it to standalone, and this standalone runs on MATLAB runtime. So whoever is installing this package should have MATLAB runtime installed. So this MATLAB runtime can be either packaged along with the application, or it can be downloaded from the web. So if you select the first option as download from runtime download from the web, so when you share the application, when the client or someone is installing the application, automatically MATLAB runtime will be downloaded from the web. Or if you have the runtime already in your computer, so you can use this include package. So when you click runtime include in the package, you get an extension called like this underscore MCR. When you download from the web, you get underscore web as the extension. Here we see a few more options here. So application information, you can change the name if you want, you can give the version and author name, email, and some details. And this is the screen which will appear like when you click on the application. This is the first picture you're going to see. And you see here two. So the simulation, to run the simulation, you need two inputs, right? From outside, that is your screen, the picture of the model, and the other one is uh, your Simulink model. Just in case if these are not included, you can add them by clicking on this button, and you can add them to the list. And by default, you'll have these three. One is a splash PNG, this is executable, and README file. And also you can add um, log files. If you want, you can click on this and give a name. So you can add log files to see what went wrong. Now let's package it. So when I click on this, this will take a few minutes for packaging. So while it is packaging, you can see that what is going on. So it will try to prompt here, like it's creating binaries. So after the packaging is done, what will happen is we will have like it will open the file where it is packaging. So I clicked on this. So whenever the operation is done, it will open the file, and in that we can see the executables. And this might take like 30 seconds, not more than that. Let's wait for it. I have already done this, but I can open that. But still, since we are doing on live, um, I'm waiting for it to process it. So now it's packaging. So everything is done, and the file is opened here on the left side. So this is what opened. So here in this, after it generates, it opens this. So we have like three files in this. If you see here, one is for redistribution and redistribution files only, and you have testing. So before you share it with anyone, we open the testing file, and this is the application. Okay. So we double click on this. So I was explaining you, right? This is a splash screen. You can have any logo or any kind of picture here. So when you're opening the app for the first time, it will take a little time. So yeah, it's app is here. Okay. So the same app which I've showed you now, it is deployed. So we can run this and see if it is working. So it's simulating now. Allow. Now we can see this. Now the simulation will be very fast. Like I change this and I can see the results like almost immediately. So it doesn't take much time. When I change it to 25 again and run it, you can see the graphs changing immediately. So this can be shared, and simulations can be done faster. So this is the testing file. Then to share with others, you can share this application. So when they take it, when they install it, application gets installed automatically. Okay. So this is one workflow we have seen now. Let's go to the second workflow. The second workflow is auto generation of app. So in the previous step, we have designed the app in the app designer. So in this, using one command, we are gonna automatically create the whole app. So this will be a template from the existing template. So let's see how it works. So first I open the model. Okay, then so this is the function. So let me go to help and open this. So you can see here, um, generates MATLAB app to to Simulink model and deploy application. You can see here it analyzes a Simulink model and generates a deployable app, MATLAB app, to simulate the model in rapid accelerator mode, like all this. So let's run this and see. So let me clear my output. Run it. So when it is generating, it will run the model again. Okay, let's save it because it says that some unchanged say it was not saved properly. So you can see now I have the model. I used one function, and you can see it is running in rapid accelerator mode. Okay, and immediately this will be converted to an app. Okay, that's it. App is created. So this is the app. So see, you see, we haven't um, we haven't given any code or anything. It understood the model. It understood what are the inputs. See, these are the inputs. We haven't given any input, so it knows what are the inputs, what are the outputs, and it generates accordingly. And to explain about the app, so what we have is this is a simulation button, and this is the stop button, and this is the time here. You can select the simulation time, and here we have parameters, radiance, temperature, and this is the model. This is the picture. This is not the model. This is only the picture. So you can zoom and like fit the screen. Okay, and here we have like 4 buttons. Okay, so when you click on this button, it creates space only for the parameters. So you see only the parameters, and when you click it back, you see the model, and when you click this, you only see the model. So this is a function of these buttons, and below you have few more buttons. Let me drag. Okay, I do this, I see the graph. So this will be the graph. Let's increase it a little more. So it is, we can see the graph. So this is a graph, and we can add, you see, you can add the layouts like number of graphs. So let's add like we want 4 graphs. So I'm adding 4. So one is current voltage. You guys know that. So let's run this and see if it is working. And you can see the display. I think you must have seen here. It says the status of the simulation. So now the simulation is ready, and you see current, power, voltage. You see all the 3 out here. I can I select this graph and I click on this and I get the current here. I click on this voltage, I get it there. Power. And here I can select both. And let's change the parameters. So it works. So this is how it is. So also if you want to see only the graphs, you can completely get big. You can observe the graphs. Okay. Now this we have seen the app. Now let's open it. Solar panel model, and I'm opening that model in App Designer. So when you create it, it automatically generates a MATLAB app file. So I'm opening it. I opened it. So you see, this is the design view, and this will be the code view. Correct. So this is all written automatically. Um, and if you have to convert this to standalone application, okay, same way. We go to the design view here. Okay, then we go to the share, and standalone desktop apps. Click on it. Okay, in this you can see that the main file is this type, and again I'm using runtime download from the web, and I have details. You see here, these are the inputs. These are the files which are required to run. And I don't see in this, I don't see Simulink model and assets. So by clicking on this, I will add Solar. This is Simulink model, Solar. And also I will add assets. So this assets has all the information related to the app. So I add both of them. Here by default, these three are created. So now let's package it. It's creating binaries. So once the package is ready, the folder will open, because since this is on. So yeah. If you want to make changes to this automatic generated app, you can also make changes. We have two workflows, right? Like one is automatic generation of app, and the other one is making your own design. So if you're comfortable with the template, so this is with the template, right? Like if you're comfortable with the template, then you can use this simulation, so automatic generation. If you're not comfortable with it, you can make your own design of your GUI. You can add some more components. You can make it more sophisticated. So I open this. So this is one. So now I'm opening this automatic generation. So now it is converted to standalone. Same features, whatever we have seen. Let's add plots. Okay, then run it and see if it is working. So I select current. This one is power. And make it big. Also, you can see this. So let's make it 1500 and run it. Oh yes. Also I forgot to inform you guys. There is also this tab called load. So from here you can load parameters and input signals. In our model, we haven't taken any input signals. So, and also you can load parameters. You can make it as mat file and you can load them into this model. So this is the app. Then you can go to redistribution, and again you can share this with your colleagues and they can run this. And okay, so let's close this. So we have seen how to create apps uh, in this one by creating in App Designer. Another one we saw how to create the app using automatic app generation. So let's this ends our ends my presentation. This video will be available. This is a recorded video. So if I have gone fast or if you're not able to follow, you can still access this video from our channel, C Simulations on YouTube. Okay, and if you're interested in the products which I've showed you, and you can contact sales@csimulations.com, And if you need any technical support, or if you want to know more about the products, you can contact support at the rate of csimulations.com. And I'm open for the questions. If you have any questions, you can put them in the chat.
Hello.
Yeah, hello, hi.
Hi, my name is Alison.
Hi,
And
Alison.
in this example you showed to us, we have a button that you can run the entire simulation as fast as possible and get the results at the end of the simulation. Uh,
Yes.
I'd like to ask you if it is possible to create an executable that can be that each run step can be controlled by another process, or we can run each step step by step, the simulation step by step. It is possible to do with these features that you showed to us, or we need to use another MATLAB feature. I don't know.
So your question is that you have a simulation and you want to run each simulation like step by step. You want to run the simulation step by step, right? So are you using MATLAB to do this? Like, are you running the script from MATLAB?
No, we are thinking to use an external process to run a model that we are building using Simulink.
Mhm.
So we would like to run step by step. I mean, if this model is running at, I don't know, for instance, 100 hertz, we need to run each 0.01 seconds. But this will be controlled for an external process.
So one solution, what I can suggest is that you can make two apps, okay? So
Okay.
one app will be controlling another app. So you make a simulation app like what we have done for the Simulink, and another app to control the another app, like to control the simulation of it.
But this model, we can use the Simulink compiler and the MATLAB compiler as well, or we need another
You need,
component like a MATLAB coder or Simulink coder.
no,
I
no,
don't know.
you need MATLAB compiler and Simulink compiler for this in this case. And you can drop us a mail explaining your purpose. Like we will try to help you, like explain
Okay.
you the whole workflow with the products. That would
Okay.
be good.
Okay. Thank you so much.
Thank you, Alison. Any more questions? You can also post your questions in the chat, or you can open your mic, and we still have like 15 minutes.
Hello, it's Danilo here. The interface, like in the example you gave, it's a fixed input and you generate the simulation. There's
Yes.
something that you can make a variable input that the user change the input along the time. Like
Yes.
if
Yes.
you're running a real-time simulation, not as fast as possible. I wanna make a real-time simulation and the user change the input like with an interface or something, or calling for another app. Another app is changing the inputs. That's possible.
Yeah, that's possible. You can do that. In this situation, in this example, I have not taken any external inputs. And also there is one more where there are some examples which I can share with you. Um, so it is like you can run the simulation, and while running the simulation, you can change the parameters and you can work in that. So there is also an example available in the documentation as tunable parameters. You can go through it for this.
Okay.
If that answered your question, did I answer? So any more questions?
I think it's okay.
So Simulink Compiler. So we can you can actually go to this page, okay, deploy standalone applications, and you can see some examples here. Examples are some examples related to FMUs. Deploy. See, the code which I've written, right? This is the inspiration. Like I took the code from this. Sorry, let me open in the script itself. See, this was the example which I've taken, and you can see in this case you have inputs. Okay, you're giving external inputs, and these external inputs are given in this. So there is also a function written for the external inputs. You can choose different types of inputs here. Some are like gated, step, and different inputs. So try to open this example, open this script, and you can find this how to give inputs. This is one thing. And the second thing is you can use, I think this one, I guess. You can change the parameters during the simulation. Yeah, in this example, you can change the parameters during the simulation when you're running the simulation, and you can see the outputs. Also, there is another way, FMU. We have not covered in this, but you can make these components and you can co-simulate with other softwares as well. This document covers almost everything. So I've chosen these examples from this and I've implemented. So one is today this is one example which I've considered. Another one is this one. Instead of having this model, we have another model. So here, this was the old app. It used to look like this. The new one, which was released last week, 2022A, has a new look. So that is what we saw. That's the thing what we saw just now in the webinar.